Hi, welcome back to Inside History with myself, Tom Lowney, and Dr. John Scholes here. We're going to be taking you up into look at the ship's fire control system, and Dr. Scholes here is going to give you a more of an insight in what specifically we're going to look at.
Specifically, we're going to be taking a look at the Mark 38 Director. This will be up at Spot 1, which is the forward main battery director position. The highest main battery director in the ship, about 116 feet above the water line. And you could consider the Mark 38 director to be the eyes component of the ship's fire control system. Originally, when the Massachusetts was designed, radar was not available, so the eyes were really just that, optical. But later on, when radar was added, we had both electronic eyes in the form of the Mark 13 radar that sits on top of the Mark 38 director, and the optical system as well.
Alrighty. So, thank you very much for tuning in, and we're going to get you right up there now. See you up there. Hi, welcome back to Inside the History here on Battleship Massachusetts. We're up inside the Mark 38 gun director, inside what small corner this would be, and this is where the train operator is, and Dr. Scholes will go into detail of it here, but as you're going to see, and I'll warn you, this is a very cramped space. Camera is hard to get in places, so it seems real tight because it is. So we're just going to go with it here. Dr. Scholes, over to you.
We are now inside the Mark 13 director in what's called Spot 1. The highest director at the top of the forward fire control tower. To give you an idea of how high we are, the optics of the rangefinder just above me here, which is a Mark 48, 26.5 foot base stereoscopic rangefinder, and probably the primary optical rangefinder for the ship. The optics are located 117 feet 5.5 inches above the water line of this ship. So we are very high indeed. The reason we are so high is so that we can see the horizon and see a potential target at the extremely long range at which the 16-inch guns can fire. In the case of this ship, approximately 21 miles. This director is a different type of director than the Mark 40 director down in the fire control tower. This is called a barbette type director, and basically, mechanically, it operates much in the same way that a gun turret does. It has a roller path with roller bearings between an upper and a lower plate, and that's how it rotates back and forth, and it's capable of training 198 degrees to the right and 198 degrees to the left. So it can actually look somewhat to the aft of the ship, but it can't cover everything. There is a second similar director mounted lower in Spot 2 to cover the aft bearings that this director cannot view. In this forward section, we have three main positions. I am sitting right now at the leveler's position. This is a telescope aligned along the line of sight, in other words, pointing at the target, which is kept on the horizon or the water line of the target in order to stabilize the ship. If we were firing on the beam, which most firing was done with the main battery 16-inch guns, we would of course be affected by the roll of the ship. And we need to correct for that. And we need to correct in the director itself, and if we're using the director to send information on level, cross level, and train down to the plotting room to the Mark 8 fire control computer, we need to stabilize that if this is going to be the primary method of stabilization. Well, what happens if, when looking through this telescope, one cannot see the horizon because of fog or night or anything else obscuring it? Well, one can use a follow the pointer system, as you see here, and turn the wheels to match the inner dial to the outer dial, and I'll do that right now, with the dial on the left-hand side until you see the arrows meet on both the inner and outer. And so this would be correcting for the level of the director, and if we were using it to control the Mark 8 computer, we'd be sending that information down electrically to the computer. If, again, we can't see the horizon, we can follow the pointer and use the stable vertical in the plotting room to provide the information for level and cross level. The next position, up a little closer here, is the cross leveler's position. This is basically a telescope that can be placed 90 degrees left or right to the line of sight. And so if we were pointing the guns on the beam, roll would be affecting stabilization along the line of sight. But pitch, where the nose of the ship comes down and up, would have to be corrected for, and that's what the cross leveler would do, basically in the same way. He keeps his telescope on the horizon, and that continually corrects. Again, he has an indicator dial here, so if he cannot see the horizon, he can follow the orders of the stable vertical by turning his hand wheels and match the pointers up, inner to outer dials. In order to maintain cross level. He has to do this on a continuous basis. And this telescope eyepiece can be flipped. And let's see, I think that's where we do that. Yeah. So we can go either left or right, depending on which one gives the best view of the horizon. I am now sitting at the trainer's station. And here, this is the place where this director acquires the target and tracks it. You can do that optically, but if you can't see, I have a screen for the Mark 13 radar, and he can place the pip in the middle of the screen and turn his hand wheels such that the director follows and tracks by keeping the radar pip in the exact center of the screen. You'll notice there's also here on his indicator giving a target bearing and a train indicator. For the director, there's a range indicator. The reason for that is this director is not located at the point where the fire control computer calculates all its calculations. That is actually located exactly at the point of the training periscope of the Mark 40 director in the fire control tower. So one has to correct for parallax depending on the range. And this is cranked in following this dial, or one can get a voice indication of what the range is until it's matched, and then a control can be thrown to put the director into automatic. It will automatically correct for parallax. There's a similar device, somewhat similar device over on the leveler station to correct for vertical parallax because we are so high above the reference point. And of course, as the range gets closer, the angle has to change in order for the director to be pointing in the right direction. Now, the trainer is the most important part of the system because he can supply corrections in train back to the computer and forms part of the closed loop spotting system. He does this in a mode called automatic. Basically what happens is that he trains the director until he has it on target and it's centered in his crosshairs. Meanwhile, the leveler and cross leveler are maintaining their position. When he has it correct, he can throw a switch here, and then the system can be thrown into automatic. At that point, his hand wheels will not be the primary control of the director train, and the computer will calculate how the director is supposed to train to stay on the target. But he can continue to look through his eyepiece. If he sees the target is drifting off, and the computer is either falling back or getting ahead, he can turn his hand wheels to match it up and recenter the target. This sends an electrical signal back down to the computer, telling the computer how to correct its solution. He can then continue to watch, and when the computer has exactly the right solution, his crosshairs will stay continually right on the target. So this is a very important part. For this reason, he is hooked up to a horizontal parallax corrector, and he's got a receiver regulator where that train information is being transmitted up from the plotting room and is driving an electric motor, and then he merely adds and subtracts to make his corrections. The trainer has this key, but this is only to indicate to the computer that he has acquired the target and is tracking it. It's just a signal, basically, to go down to the plotting room to say, I'm on target, and I'm tracking, and I'm following it, and they can then shift the system into automatic if they wish. You'll see two keys here on the cross lever's wheel. One of them is a salvo signal buzzer to say, I'm about to fire a salvo. The other one is the actual trigger. This would only be used when the director would be in what's called selective cross level. In other words, the automatic system was not correcting for level and cross level, and you had to pick a point in the cross level, say the pitch of the ship, at which the ship was approximately level. He would be looking through his telescope, and when the ship came on level and we were in the selective cross level mode, he would then close the firing key, and that would complete the firing circuit. And I'm now back over at the leveler stand, and a couple of other pieces of equipment to point out. This also has two keys on it. One of them, again, is the salvo buzzer, and the other is the firing key. As if we were firing a selected level. In other words, the ship was rolling, and we want to fire when the ship is at level and the crosshairs are on the horizon. We would give a warning, and then when the crosshairs came on, pull the trigger. There's one other trigger here, which is when this director is being used in automatic and level and cross level are being provided by the stable vertical and we're in automatic, or when we're actually doing the tracking ourselves, but we're not firing at a selective point in the roll, we're firing anywhere on the roll because we're leveling and cross leveling and keeping the guns automatically on target, then this is the automatic firing switch. So in this case, the pointer holds this switch down continuously so that whenever the guns are ready to fire, they don't have to wait until it reaches a certain point in the roll, in the level, in order to fire. Now, because we are so high above the reference point for the main battery, we have a vertical parallax as well as a horizontal parallax. And that has to be corrected for range. And so there's a device here where one can set range settings for the 0. And then again, if the director goes into automatic, it will automatically correct for vertical parallax continuously from that point. But the initial setting has to be matched up using this device. Okay, we're now standing in the after half of the Mark 38 director behind the Mark 48 26.5-foot stereoscopic rangefinder. There would be two people manning the rangefinder. One will be the rangefinder operator looking through his eyepieces here in order to measure the range to the target using stereoscopic range marks. That requires that he has perfect stereo vision in both eyes, but they would look at recruits very carefully about their eyesight, and if they happen to have that, they would become rangefinder operators. There is also a second relief rangefinder operator who is also the guy who reads the range information and has a sound-powered phone and acts as a talker for the Mark 48 rangefinder and also for the director itself. Now, staring through this rangefinder and measuring ranges is rather fatiguing. You'll notice there's no place to sit, and it's quite a strain on the eyes. So every half an hour or so, these two people would switch positions, and a fresh guy would get on here and measure ranges, and the other guy would then assume the other duties of reading off the ranges and being the talker. Now, additional information, additional equipment was added in here when the Mark 13 radar was installed. It's on the top roof of the director, and this is a lot of this is equipment for this. So this would also be operated usually by the assistant rangefinder operator. As you can see, there isn't much room for anybody else in here. So I'm now standing also in the aft portion of the Mark 38 director, only this time at the spotter's position, who's also the director control officer. Above me is where a periscope would be mounted, and he can use this to scan and also measure the bearing to it. And this can be one way to acquire a target. If he acquires a target, he can then instruct the trainer to train right or left to a particular bearing and acquire the target. The trainer will then respond once he's on target and say target acquired and tracking, and then the tracking can begin. But he can also acquire targets other ways. He has a Mark 13 radar scope here. So again, he can acquire targets by centering them in the scope and then relaying that information to the trainer, or the trainer has his own scope and he can simply match the picture that's generated here. There are also indicator dials that come from the plotting room and CIC, which give the bearing of a target, and so he can again tell the trainer train to bearing 100 degrees relative, and you'll then train over to that bearing, or you can give it in a true bearing as well. A couple of other features of the rangefinder can also be pointed out from here. This is one way that the rangefinder can be stabilized by simply a handle. So this would be correcting for the leveling of the rangefinder to keep it on target, but this is the absolute last backup mechanism. There are several other mechanisms. There is a stabilizer specifically for the Mark 48 rangefinder, which is basically a stable vertical that drives the rangefinder, or this can also be hooked up through the trainer's station to the stable vertical down in the plotting room and use that to stabilize the rangefinder, which should also then stabilize the trainer's optics. And there's another rod that goes up through the roof that stabilizes the Mark 13 radar and holds it level on target as the ship rolls. Now, the spotter is often the primary control operator for the 16-inch main battery. Therefore, he needs all the information to be able to control the battery. For example, this is a turret train indicator, which shows where every turret is being trained to be on target. He has sound-powered phones to communicate with the plotting room and everybody else on the gunnery control circuit. And so the battery can be controlled here. The director can also be independently used to aim the guns. This does not benefit from all the sophisticated equipment with the Mark 8 computer and the stable verticals, but it can provide gun orders by itself through the trainer tracking optically and the leveler and cross leveler leveling optically. So there are, again, multiple options and backups for control. And this was a very, very effective system with the Mark 13 radar particularly, which had a range of up to 80,000 yards. One could track targets by radar out to the maximum range of the guns and beyond. I hope you enjoyed your visit to the Mark 38 Director. I imagine you've noticed just how crowded it is. This sometimes in Navy slang is referred to as a sardine can because everything is packed in so tightly. Why packed in so tightly? Well, we are way above the waterline. Every inch that we make bigger requires more weight of armor in order to protect this. Everything has to be made larger and bigger and therefore heavier. That weight above the waterline adversely affects the ship's stability. So there is a limit to how much weight you can put up this high in the air, even in a huge ship with a 108-foot beam, such as a battleship. So everything is squeezed down as tight as possible to reduce the amount of armor weight and other weight up this high for stability purposes. Also remember, these ships were designed under the Washington Treaty of Limitation of Naval Armaments. They were not supposed to exceed 35,000 tons standard. Every pound that you add up here, you have to subtract from the armor on the 16-inch guns, or the amount of ammunition you can carry, or something else in the ship. So that's why everything here is made as small as possible. We're now training the Mark 38 Director with the trainer's hand wheels. Notice that it rotates exactly in the same manner that a gun turret rotates. This training is exactly how it would look if the director was tracking a target and following it in train. Notice also that the Mark 13 radar trains along with it, and therefore is pointed at the target just as the optical components of the Mark 38 Director are pointed at the target. This is the trainer's port, trainer's telescope. The director would be in this position firing at a target approximately off the beam on the starboard side of the ship. The leveler then would be compensating for roll, and the cross leveler would be compensating for pitch. And it goes back to the 0-degree bearing looking dead ahead, and the leveler would be compensating for pitch, and the cross leveler would be compensating for roll.
Got some great insight and in-depth knowledge about the main battery fire control systems, both in Spot 1, our armored control center for the fire controlman, and Dr. Scholes, thank you very much for the insightful and deep knowledge of that. I got a few things out of it, and I'm even a gunner's mate, and there was a lot that I wasn't aware of. And to get in there and show you the spaces, we can only do that and get these spaces open to the public with your help. So if you want to come down, volunteer, jump into the thick of things, contact our coordinators here, call, set up a time. We'd love to have you come down and get into it. You can also help by either donating, liking, sharing, or subscribe, and get us back to where we can present you our history. I want to thank everyone for tuning in and seeing what we have here to offer. There's so much more. Stay tuned. More is coming to you. We're going to bring it to you because this is your ship, American Fleet, our history, and we want you to share in it. Thank you for your time. I'm Tom Lowney, Gunner's Mate retired. Thank you.